yesterday's class. Today we will move forward and see database machine architecture. So slowly we are getting into the thick of the things, the technical aspects of the database. So from today onwards, you need access to the lab. Okay, so you'll be slowly starting the lab access practices. Okay, and learning more about the hands-on approach. Now, just to recap the architecture, database machine architecture. You know, database machine has database servers, storage servers, and InfiniBand network that connects database servers with storage servers. So this slide shows you a quarter rack system. In quarter rack system, you will have 2 database servers, 3 storage servers. And this slide also shows you the software installed on each of these servers. If you see the database servers, okay, on every database server we install either Oracle Linux or Oracle Solaris as per customer choice. Okay, then we install Oracle Grid Infrastructure and we install Oracle database binaries. And when it comes to the storage server, on each storage server, the operating system is Oracle Linux, and we install Oracle Exadata storage server software. Okay, so and all the servers in the database machine are Sun servers. So the hardware is Sun hardware. Okay, now if you see this diagram, as a DBA, we are already familiar with all these softwares. We know Oracle Linux, or we know Oracle Solaris. We know Oracle Grid Infrastructure. We know Oracle databases, right? And the only piece of software that is new to us is Exadata storage server, right? So this software is installed on every storage server, and it is responsible for managing the storage devices attached to that server. Yesterday we also learned every storage server has 12 number of hard disks. Okay, irrespective of the version, every storage server has 12 hard disks, and apart from hard disk storage, Exadata also uses flash storage, SSD storage. So every storage server has 16 flash devices. Okay, 16 number of flash devices. So all these storage devices, all the storage is managed by the software Exadata storage server. Traditionally, we have different storage servers available in the market. Different vendors has different softwares. For example, EMC has their own storage server software. IBM has their own storage server software. Okay, so instead of using existing storage server softwares, Oracle has developed their own storage server, because the existing storage servers are not optimized for Oracle database I/O. They are not designed for Oracle databases. So you can use them for any general purpose storage. Okay. So because of that, Oracle did not use them. Oracle has developed their own storage server, which is optimized for Oracle database workloads, which has many features that optimizes Oracle database performance. So in a way, it is custom built, it is purpose built for Oracle databases. Okay, so because it is new to us, this is going to be our major focus throughout the course. Okay, so let us start understanding this Exadata storage server software and its components, okay, at a more granular level. So let us start with the basic understanding of Exadata storage server, okay. So actually we know Exadata is a very powerful machine. When you run Oracle database on Exadata, your database performance is much better when you run the same database on the traditional servers. The reason for this is twofold. One is Exadata features high-end hardware, okay. So because of high-end hardware, you get performance benefits. More than hardware benefits, the main performance comes from Exadata storage server, okay, which manages the storage. Exadata storage server has many intelligent features. All these features contribute towards your database performance. So that way, the performance benefits come both from hardware as well as software features. So in my opinion, more than hardware, it is the software. It is the Exadata storage server that powers the performance of the database. Okay. So Exadata storage server is a high-speed storage server developed by Oracle, designed for Oracle Database I/O, optimized for Oracle Database I/O. So its main purpose, its only purpose is Oracle database. Okay. So it has many intelligent features built by Oracle. Okay. These intelligent features are not present in third-party storage servers, the general storage servers available in the market. So these features make Exadata different from other storage servers. So what are those features? Exadata storage server has a feature called Smart Scan, a feature called Hybrid Columnar Compression, HCC, a feature called Flash Cache, Smart Flash Cache, a feature called Smart Flash Log, and storage indexes, and IORM, IO Resource Management. So these are some intelligent features which are built into Oracle Exadata storage server. Other storage servers doesn't have these features. That way, when you use Oracle Exadata storage server for your storage management, your databases get maximum I/O performance, which contributes to the overall database performance. So in a way, you can think of Exadata storage server equivalent to your traditional storage server with these intelligent features. Okay. So without these intelligent features, Exadata storage server is similar to your EMC server or IBM server or Dell server, any other server available in the market. Okay. Now, this slide shows you the database machine architecture. Okay. This slide has 3 database servers, 3 storage servers, and both are connected with InfiniBand network. Right. Now, if you see, this ESS is your Exadata storage server. ESS is installed on every storage server. Okay. And ESS manages the storage devices attached to that server. These storage devices are in the form of hard disks as well as flash disks. And nowadays, Oracle is shipping storage server only with flash storage. those servers are called as extreme flash storage servers. Okay. Now, the storage server software is pre-installed by Oracle. In fact, it is a small software, okay, which is around 900 MB in size, okay, and it is installed as an RPM on Linux. So it doesn't have any separate installation process also. It comes as an RPM, okay, a package. On Linux, we install it as a package. Now, after installing Exadata Storage Server RPM, Exadata Storage Server has three main services, okay, or three main background processes which provide these services. Like every database server has background processes in the form of database writer, log writer, checkpoint, SMAN, PMAN, so on, right? Similarly, every storage server has some background processes. So when you start the storage server, these background processes will be started at the operating system level. So this slide shows you the background processes or the services provided by each storage server. Okay. So basically there are three services, okay, which are implemented using three background processes. Their names are cell server. Then MS stands for management server. Then RS stands for restart server. So these are the services or the background processes related to storage server. Unlike database server, it doesn't have many processes. It has just three processes, but these are implemented as multi-threaded processes. So at OS level, you may see multiple threads or multiple process related to these three services. So that is the concept. Every storage server has three background processes in the form of cell server, management server, restart server. Okay. Now, out of these three, cell server is the main background process or the main service. Cell server manages the storage. Okay. Anything related to storage is managed by cell server. Cell server also communicates with every database server. Okay. For any storage request, for any IO request, the cell server communicates with the database server. On the database server, you have a special library, okay, which is responsible for communicating with the cell server. So this library is generally called as libcell. Okay. So if you go to your Oracle database binaries starting with 11.1, you will see a new library, libcell. Okay. So this libcell communicates with the cell server. Libcell is on the database server, cell server is on the storage server. So that way the communication between the database server and the storage server is facilitated through libcell and cell server. Okay, see this? So that way the handshake, the communication happens between a database server and a cell server and vice versa, from cell server to database server. Okay. Now, just to compare and contrast how an IO request is processed on the database machine, Exadata database machine, this slide shows you the process. Now, so this slide has three sections basically. This is your compute grid or database server grid. The second part has two switches. This is InfiniBand networking part. So this is networking layer. The last layer is your storage grid, storage servers, right? So in this diagram, I have two database servers, three storage servers, right? And connected with InfiniBand network, which has two InfiniBand switches. Now, let us see how the database IO request is processed on database machine. A session issues database IO. A session connected to database server and issues an IO request. So as usual, the server process serving that session, right, checks for the matching blocks in the database buffer cache, right? So that is, we are calling it as logical IO. If the block is available in the buffer cache, there ends the matter. So the blocks are processed and served to the client. If the blocks are not available in the database buffer cache, then what should happen? Now physical IO is required. Yes, these slides are there in your slide deck that I shared with you. So if the blocks are not present in the database buffer cache, now physical IO is required. The server process constructs something called IDB message. Okay, so you know, on Exadata, the communication protocol is IDB protocol. So any communication to the storage server happens in the form of an IDB message. Okay, so the server process constructs an IDB message and sends this message over InfiniBand network, okay, to the storage server. So the IDB message pass through InfiniBand network. Okay, now this IDB message transmitted over InfiniBand, okay, then reaches to the storage servers, and this message is parallelly transmitted to every storage server in the database machine, because the matching blocks may present on any of the storage server. So any IDB message will be parallelly transmitted to all the storage servers. Now, once the IDB message reaches to the storage server, the cell served on the storage server unpacks the IDB message and issues the IO for disks, disk IO. Okay, and now here comes the intelligent feature. Exadata storage server has an intelligent feature called Smart Scan, right? So as required, the storage server may perform Smart Scan or regular block scan. Okay, so in Smart Scan, what happens? Every block will be scanned at the storage server level itself, and only those matching rows from the block will be sent back to the database server instead of transmitting the entire block. Okay, so that is the essence of Smart Scan. So SQL processing will be done at storage server level, and block filtering will happen at the storage server level, and only the matching rows will be transmitted to the database server. Traditionally, this is very different. In traditional processing, we know the storage server transmits the entire block. Okay, so in Oracle, the minimum unit of IO, the atomic unit of IO is a block. Okay, so every block will be transmitted to the database server, and the block level processing will happen at the database server. So that way, the cell server sends the data, the matching data, or the entire block as required to the database server over InfiniBand. And the InfiniBand transmits the message and the data to the database server. And on the database server, the server process reads the message and resumes the further processing. So that way it receives the messages from various storage servers and aggregates all these results and transmits that results back to the client. Okay, so this is traditionally similar to your traditional processing. Only thing is, in the case of Exadata, the block scanning happens at the storage server as required, and only the matching data will be transmitted to the database servers instead of transmitting the entire block. Okay, so this is just to give you an overview vision of this. We will be understanding Smart Scan. We have hands-on practices around the Smart Scan at a later stage. How does it work in the buffer cache? See, before issuing an IO request, the server process checks for the blocks in the buffer cache. If the blocks are already present in the buffer cache, all this processing is not required. Okay, so directly the blocks will be processed and the result will be sent back to the client. If blocks are not present in the buffer cache, then only this processing model comes into picture. A physical IO is issued and the IO is issued in the form of IDB message. IDB message is transmitted over InfiniBand network. IDB messages reaches every cell. On every cell, cell server unpacks the message, issues IO request, okay, then filters the matching data at the storage server level itself and sends only that matching data to the database server. So the traditional processing is same. Okay, you have additional processing here as required. This additional layer will be used. Sai, did I address your question correctly, or you are?
Yeah. Sorry. Can you hear me?
Yeah. Please go ahead.
Okay. So the reason further, I want to know, okay, it gets the the filter at the cell server level, and the server process gets back or IDB message converts back to SGA into buffer cache.
Right.
So when it is returning the rows in the buffer cache, it also stores as a like a blocks, right?
Right.
So how the further going like undo blocks and the redo blocks will be converted? I mean, is that conversion done by the IDB while it is transferring into the buffer cache, or I mean, when you say it works like a traditional, after that,
No.
how?
Here, let me interrupt you here. The Smart Scan, okay, doesn't read the data into buffer cache.
Oh, okay.
Okay, it reads the data directly into the PGA of the server process.
Okay, got it.
Okay, yeah.
Okay.
Yeah, we'll learn. We
So
have
that's
topic.
something like direct path reads, right?
Yeah, direct
like,
path.
Exactly.
Exactly. You got that.
Okay.
See, in fact, for Smart Scan, the condition is direct path reads.
Oh, okay.
Correct.
Got it. Thank you.
Yeah. So we will discuss more about Smart Scan. We have dedicated topic. We have hands-ons to verify that Smart Scan at a later stage. Just to give you an idea of how the processing happens and different in Exadata. I mentioned this slide. Now, let us understand the network architecture in Exadata. Okay. Every Exadata database machine has a different networks inside the rack. No problem. No problem. Anytime you can raise a question. Okay. So Exadata database machine uses different networks, up to 5 networks. Okay. So let us see what are those networks configured in Exadata and the purpose of each network, and more details about the network interfaces. Exadata has different networks like client access network. Okay, this is same as your regular systems also. So client access network is used by clients accessing the database servers. So ultimately it is nothing but your LAN. So client access network is your LAN, okay, to which the Exadata database servers are connected, so that the clients over the LAN or WAN can access the database servers. Then Exadata has InfiniBand network, which is a private network. Okay, we know this. InfiniBand network connects the database servers and Exadata storage servers. And when you run Oracle RAC, the same InfiniBand network is also used as a RAC interconnect. Okay, RAC interconnect. Then the third network is management network. This management network is used for administrative tasks on the database machine and the various components of the database machine. Every database server and storage server has two network interfaces for management. They are named as NetZero and ILAM. Okay. NetZero provides management access to the operating system. ILAM provides management access to the hardware. Okay. Management access to the hardware. So this is probably new for us. Traditionally, in a rack configuration, when you deploy Oracle RAC on traditional hardware, you know, client access network, nothing but your public network. And in RAC you have private network, right? So here the private network is InfiniBand. Okay. And apart from these two, Exadata features management network. So as the name suggests, management network is used for managing the components of the database machine. Okay. And only the administrators will use management network. So with a separate management network, administrators connect to the database machine through a separate network. So that way you have more security. Your management traffic is separated from the regular client access traffic. Okay. So to facilitate dedicated management, you have two network ports on every database server and on every storage server. And when it comes to management, you have two types of management. One is hardware management, which is done by the hardware team, and the software management, which is done by the sysadmins and database admins, right? So generally the sysadmin team and the database admin team need a SSH connection to the server. to access the operating system and all the softwares on the server. So that is facilitated using NetZero interface. Then the hardware team requires access to the hardware. Okay, so they can remotely monitor the database machine server hardware. They can remotely start the servers. Okay, power off the servers, power on the servers. Okay, monitor every component on the server, monitors the LEDs blinking on various components, okay, remotely using something called ILAM. Okay, so that is ILAM interface. We'll learn about more about ILAM in the next few slides. Okay. Now, apart from these three networks, these are compulsory. Okay, client access network, InfiniBand network, management network. Okay, these three are compulsory, configured during the initial configuration of the database machine. Next, apart from these three networks, uh, clients can configure additional networks. There are some additional unused network interfaces on the database server, so that you can configure additional networks to connect your database machines to, okay, backup servers or ETL servers if you are in data warehouse environments. Okay, or the database machine can be connected to Exalogic elastic cloud machines, okay, which runs your applications. So to facilitate external connectivity, okay, you have some unused network ports on the database servers. Okay, now we will learn more about the network architecture with this diagram. Um, 1 minute, I am getting a call. I need to attend this call. Just okay, sorry guys for that. This is some important call. Okay, now this is the network diagram used in Exadata. So let us understand the networking features with this diagram. Now basically in this diagram you have database server, right, or servers. You have Exadata storage servers. Please observe the cursor when I move. So you have database server, you have storage server. Each server has network interfaces. If you see on the storage server, you have ILAM interface, net0 interface, and something here bond IB0 interface. Okay, so basically you have 4 interfaces on the storage server. Then on the database server, you have many interfaces. Okay, ILAM, net0, net1, net2, net3, okay, port A, port B. Okay, so these are all the network interfaces used to implement various networks. And you have a Cisco Ethernet switch. Okay, then you have InfiniBand switches. Okay, and you have power distribution units. So these are all the components of a database machine, Exadata database machine. So you have database servers, you have storage servers, you have InfiniBand switches and InfiniBand cables, you have Ethernet switches and Ethernet cables, and you have power distribution units. Okay. Now look at this legend. The brown one is the management network, ILAM network. The red one is your client access network. The blue one is your InfiniBand network. Okay. Now first start with InfiniBand network. You know InfiniBand network connects database servers with storage servers, right? So the blue one is your InfiniBand cables. And InfiniBand network is implemented with InfiniBand cables and InfiniBand switches. In this diagram, you see different types of InfiniBand switches. One is called leaf switch. Second is called spine switch. Okay. And you have 2 leaf switches, leaf switch 1, leaf switch 2. And you have one spine switch. Spine switch is present only in half rack and full rack configurations. Okay. Now, on every database server and every storage server, you will have 2 InfiniBand ports. Okay, 2 InfiniBand ports, and for better throughput and high availability, these are bonded together. These are bonded together to tolerate the failure of a single interface. And one wire goes to one switch, one leaf switch. Second connection goes to a different switch. So that even if one interface fails, okay, even if one interface fails, the traffic will continue through the other interface. Even if one switch fails, okay, the network will use the second switch. So that way, this network is configured in a fault tolerant fashion. Okay, let me first explain this. I will come to your question. Okay. Now, so that is the InfiniBand network. So what is the use of InfiniBand network in Exadata? It is used for 2 things. One is to connect database servers with storage servers, right? And second purpose is, if you implement a rack, the InfiniBand is also used for a rack interconnect communication. So database servers communicate with each other. Okay. So for that also we use InfiniBand networking. Okay, which is not shown separately in this network. Okay, because You may run rack or you may not run rack. But if you are running rack, every database server is also interconnected with other database servers using InfiniBand networking. Okay. Next. And you saw two types of InfiniBand switches. Leaf switch, which connects database servers with storage servers. Then spine switch. Spine switch is used to form multi-rack configurations, to connect one rack with another rack. Okay, we use spine switch, and the spine switch is present in half rack and full rack configurations only. Okay, half rack and full rack configurations only. Next, now see the client access network. Okay, the second one is client access network, which is the red one. Now on every database server you have many ports for client access, and the clients access only database servers. Okay, that's why on the storage server you don't have any client access network configured. Okay, and on every database server you have multiple ports available for client access. Okay, basically net 1 and net 2. So again, for failover purpose, these two ports are bonded together. Okay, so that even if one port fails, clients can access the server through the other port. Again, you can configure additional client access network. Okay, this you see the dotted line is optional network. So many customers implement redundant networks. In case if one network has problem, clients can access through the redundant second network. So the same can be implemented on Exadata also. Okay, so that is your client access network, and the client access only for database servers and not storage servers. Then third one is management network. Okay, under management you have two ports on every server. Okay, net0 and ILAM. Again on the storage server you have net0 and ILAM. Again on every component like PDU you will have a management port. On InfiniBand switch you will have a management port. So all these management ports are uplinked, connected to an Ethernet switch, which is connected to the management network, so that you can perform remote management of all these components, remote monitoring of all these components using OEM, Oracle Enterprise Manager 2. Okay, so this is more about the network architecture. Okay. Any questions now on this part? Sai, you were asking something. Did I address that as part of this discussion, or no?
Yeah. I mean, yeah. Always, the reason I asked because it's not diagrammed, but yeah,
Right.
as you mentioned, yeah, if it's rack, then there is a possibility.
Correct.
But so the question now is, the Infinity ports are just two on database server and storage server, right? So if there's a case, if you are implementing the rack, then do we have because interconnect does not use the IDB, what you call the protocol, right?
Right.
So, so what port do we use if at all, if we want to go with the rack?
Actually, it is InfiniBand port only. Maybe this diagram doesn't reflect that properly. I will have to update this diagram. Okay.
Okay.
Yeah.
So
actually, this is
the
X4 diagram. I think I need to change this for X5, X6.
Okay.
So it is still InfiniBand port, okay, used for rack interconnect.
Got it.
Okay. Now, let us learn more about InfiniBand network. So as we discussed, InfiniBand is the database machine interconnect fabric, which connects your database servers with storage servers. And InfiniBand is the latest networking technology which has very high bandwidth and low latency, and provides transfer rates up to 40 GB per second in each direction. Okay, half duplex or duplex. Okay, single direction or both direction. And InfiniBand is widely used in high performance computing. It is not commonly used in data centers. It is sparingly used as of now because it is very costly and still under R&D kind of thing. It is still maturing in the technology. And in Exadata, InfiniBand is used for storage networking, rack interconnect, and if you are connecting database machines with external servers, okay, again you can use InfiniBand so that you get high performance connectivity with the external servers. For example, you want to connect your database machine with backup servers in the data center. So you can use Ethernet LAN or InfiniBand network. When you use InfiniBand cables, InfiniBand network, the data transfers will be at a very high speed. Okay. Similarly, you can connect database machine with Exalogic machine. Database machines runs databases. Exalogic machine runs applications. So you can connect database machine with Exalogic machine with, again, InfiniBand network. Similarly, if you have ETL servers in data warehouse environments, you can connect your database machine, Exadata database machine, with ETL servers using InfiniBand network. Okay, so that way it can be used in different ways in Exadata. And it looks like a normal Ethernet to host software, meaning all your IP-based tools, okay, work transparently with InfiniBand network also, like your SCP, okay, SSH, Telnet, if you are using, all these things transparently work on InfiniBand. They doesn't need any special configuration or tweaking. And you know, InfiniBand network consists of InfiniBand cables and InfiniBand switches. Each InfiniBand switch has 36 ports. It is a 36 port data center switch, and out of these 36 ports, 6 ports are unused. They are reserved, okay, for external connectivity. Just we discussed, right? You can connect it to backup servers, you can connect it to ETL servers, you can connect it to Exalogic, okay, or if you are implementing DataGuard, standby database, so you can connect a standby database with your primary database using InfiniBand for high performance data transfers. Okay, so that is the external connectivity. Next, we discussed this earlier. In database machine in Exadata, the protocol used is IDB protocol. Oracle doesn't use your general purpose protocols, okay, like TCP/IP, okay, or your iSCSI protocol, NFS protocols, generally used in data centers, right? But Oracle uses a special purpose protocol built exclusively for Exadata, okay, called as IDB protocol. IDB stands for Intelligent Database Protocol. Okay, so it is a unique data transfer protocol used to transfer data between database servers and storage servers. Okay. Why Oracle is using IDB instead of using the regular protocols? These regular protocols, okay, are general purpose. They are not built for, again, Oracle Database I/O. So the general purpose protocols operate only on the low level blocks of the disk. They transfer blocks, not a part of the block. Okay. Whereas IDB is aware of Oracle block representation and transparently maps database operations to Exadata operations and transfers entire block or a part of the block, okay, from the storage servers to the database servers. So the general purpose protocols transfers entire block, whereas IDB protocol can transfer entire block or a part of the block, only the matching result, matching rows to the database server. Okay, so that way it is more efficient. Okay, when it comes to data transfers, and it uses InfiniBand for this transfer, so that way your transfer rates will be much higher in Exadata, and it is the required protocol in Exadata for enabling smart scan feature. So the smart scan feature relies on IDB protocol. It doesn't work on general purpose protocols. Okay, and IDB is developed by Oracle for Exadata. So that is about IDB protocol. So remember, Exadata uses IDB protocol to transfer data between storage servers to database servers. IDB is developed by Oracle. IDB protocol can transfer entire block or a part of the block. Okay. Then let us see management or monitoring of database machine. Now you know Exadata database machine has different components. Okay. How to manage all these components? How to monitor all these components? For example, you have database servers, you have storage servers, you have InfiniBand network which has InfiniBand cables and switches. You have Ethernet networks which has Ethernet cables and Ethernet switches. You have power distribution units which powers the entire rack. Okay, so it powers all the components of the entire rack. So when it comes to database machine, the administrator, okay, the role is called DMA, database machine administrator. Whoever is managing the database machine is called as DMA, database machine administrator. So traditionally our role is a DBA. When you manage a database machine, your role is now called as a DMA, database machine administrator. So the DMA has to monitor, has to manage every component present in the Exadata database machine. So how do you do that? Okay, there is one single tool which supports management and monitoring of all the components of the database machine. That is your Oracle Enterprise Manager. Because Oracle Enterprise Manager is Oracle's own tool, so it is integrated with the database machine. So using Oracle Enterprise Manager, the DMA can monitor every component of the database machine. Apart from Enterprise Manager, each Exadata storage server has command line interface to manage and monitor the storage servers. Okay, so this is called as CellCli. CellCli is the command line utility used to manage individual storage servers. Individual storage servers. You have one more utility called dcli, distributed command line utility, which is used for managing multiple storage servers centrally. Okay, so that way you can use cellcli and dcli utilities to manage storage servers. But if you want to monitor all the components through a single monitoring tool, that is your enterprise manager. There is no other tool which is capable of monitoring every component of the database machine. Okay, but that capability is provided by your enterprise manager. So on the field in real time, almost every customer who purchased Exadata has enterprise manager. Okay, so obviously in real time you will use enterprise manager for monitoring purpose, if not for administration. Okay, though you can still use it for administration purpose. Okay, the main use is for monitoring purpose. Now we saw ILAM interface. ILAM may be probably new to us, but not to the hardware team. Every hardware team in the organization would know about ILAM. Okay, as a DBA, we are not maybe familiar with ILAM. Let us learn more about ILAM, which is used on database machine. So in simple words, ILAM is used to manage hardware components remotely. Okay, so it provides remote hardware management capability. Okay, so ILAM is a dedicated system of hardware and software that allows you to manage the Sun servers independently of the operating system. Allows remote management of database machine servers. So in database machine, you have database servers and storage servers. If there is any hardware problem, how do you monitor that? Okay, or if I want to power off a particular server, how do you do that? Or if I want to power on a particular server, how do you do that? Okay, so you have to get into data center and physically touch that power button, right? But most of the time we do remote administration. So how do you remotely monitor your hardware components, manage your hardware components? So for that, every Exadata server, every server on the database machine is equipped with something called ILAM. ILAM has its own hardware, its own software, and this hardware and the software runs independent of the server hardware and the software. Even if the server hardware and the software is powered off, your ILAM is available so that you can power on, power off the servers. Okay, so with ILAM you can remote manage the server hardware. You can see the LED status, okay, whether the LED lights are blinking for every component. If they are blinking, they are in green, yellow or red. Okay, you can see remotely. You can power on, power off all the servers remotely, and you can do, okay, remote media management. You can eject, okay, you can mount ISO images, CDs, USB drives remotely. Okay, so that is the capability provided by ILAM. With ILAM, you don't need to get into data center to manage your hardware. Okay, so ILAM is a separate hardware and a software module which sits inside the main server. Okay, and technically speaking, the ILAM power should be a different power source from the server power source, because one important point is ILAM should be always powered on. Okay, so that you get this remote management capability. If ILAM is powered off, you cannot remotely access the server hardware. So then you have to get into the data center to manage the hardware. So ILAM provides out of band management, meaning the server power cable is different, ILAM power cable is different. The server power source is different, ILAM power source is different. If you connect them to the same power source, if there is a problem with that power source, both these things will go down. Your server will go down as well as ILAM will go down. So that means now you don't have remote management facility. Okay, and ILAM, you can access ILAM from server host using SSH. ILAM has web interface. ILAM has command line interface. Okay, and ILAM has SNMP interface. ILAM has IPMI interface, and ILAM can be easily integrated with any third-party tools like OEM and BMC tools, CA, Unicenter, HP OpenView, so that you can monitor from those tools. For example, this slide shows you how to SSH to ILAM from the server. Every ILAM has an IP address and a host name, which is configured during the initial database machine configuration. So you log into ILAM the way you log into any server using SSH. So this slide shows you how to SSH to ILAM. ILAM has its own username passwords, its own host names, its own IP addresses. Then once you log into ILAM host, you can use ILAM specific commands to view various details about the hardware and the environment of the server. So this slide shows you how to display the temperature details of the server. Okay, this is the command. Okay, and then ILAM also has command line interface. Okay, it has its own commands which are typed once you SSH to ILAM. Okay, then ILAM has graphical interface. If you don't want to learn ILAM commands, okay, you can use graphical interface. So once you log into the graphical interface, it looks like any other graphical tool like OEM. It shows you all the servers, each component of the server, the power state, the LED indicator, various details about the component, the model, the firmware, the software, everything, the serial numbers of that component, everything graphically is shown to you. So without knowing any commands, you can see every component details, and you can switch off, power on every component through the graphical interface. So this is something about the database machine architecture, the hardware architecture, the networking architecture, how to monitor the hardware components using ILAM and all that. So that's it for today.